Okay, so we've got some terms here that we're going to be looking at when it comes to solutions and chemistry, and one of them is obviously solution. A solution is a homogeneous mixture, which means a solution, you can't really tell the parts when you look at it. So for instance, if you dissolve salt into water completely, you can't tell that there's salt in there unless you taste it, okay, or run other tests on it or let it evaporate. So homogeneous or homogeneous mixtures are solutions. Okay, so it's another term for that. The solute is the substance being dissolved in the solution. So with our example of salt and water, the salt is the solute. Okay, it's usually what you have less of in the solution. Okay, the solvent in our case of salt and water would be the water, and this is the substance doing the dissolving. So water will come in, it'll grab those ionic compounds or things like sugar, and it surrounds the particles and pulls it apart and dissolves it so that you can't see it anymore. So usually water is our solvent. In chemistry and in everyday life, there's water in everything: fruits, vegetables, every drink that you guys drink has water in it, including milk. And so water is known as the universal solvent. It's good at dissolving a lot of different things, not everything. Oils can't be dissolved by water because oils are nonpolar, water is polar. If you take the solvent and you add the solute, you get a solution. So those two things together make up the solution. So we use a term called molarity as our unit for solutions, and we're going to look at that in just a second. But molarity is a rate of moles per liter that we are going to look at. Okay, so we have molarity. Let's talk about what this is. Molarity is a unit of concentration used in chemistry, and concentration is how much stuff is in a certain volume. Okay. For this, we have an equation that's given to us. It's molarity, which is capital M, equals moles of solute over liters of solution. Okay, so we have this moles on top, liters of solution on the bottom. Now, when I say solution, I mean the solute plus the solvent. So it's everything in the solution. If we have a swimming pool and a bunch of people jump into that swimming pool, the level of the pool is going to go up. So the volume's got to be everything. Okay, in that. So here's an example. We have 2 moles of NaCl dissolved in water until 2 liters of a solution of NaCl in water is formed. And the question is, what is the molarity? What is the capital M on this thing? Okay, so we're going to go through how to set this up. So if you look at the setup here, I've got the 2 moles. That goes on the top. The 2 liters goes on the bottom. And we divide, and you guys know that 2 divided by 2 is going to be 1, and it's 1 mole divided by a liter. Well, instead of writing moles divided by liters, we usually write a capital M in chemistry, which stands for molarity. It's still a rate. It's 1 mole per 1 liter. In fact, we can even write it as 1 mole over 1 liter, and I don't care which way people write it. The M's just often easier to use for that, okay? So that's the first thing. So then here's how we would say this in chemistry. So if I was reporting my work like with my mouth and saying it, I would say this is 1 molar, or this solution is 1 molar. Okay, so that's just a little bit on how we speak in the language there. Okay, let's look at a practice problem. It says a solution of sodium fluoride, that's NaF, contains 84 grams of sodium fluoride and enough water to make a 1.5 liter solution. What is the molarity? Now in this one, they didn't give us moles, they gave us grams, but if you remember your mole stuff, we can make that swap pretty easily. So I look at my setup here that I'm showing you guys, and the grams are given amount that goes in the top left. The 42 grams is coming from the periodic table. If you add up a sodium and a fluorine from those masses on the table, the grams cancel out and we're left with moles of sodium fluoride, and we have 2 moles of sodium fluoride. So that's step 1 in a problem like this. Okay, step 2 is to put it all together. So they gave us the 1.5 liters of solution, and remember, that's the whole thing, solute plus solvent. That's going to go in the bottom here. Okay, the 2 moles we calculated in the first part goes in the top, and you just divide the two numbers, 2 divided by 1.5, and you get 1.33 molar sodium fluoride. Okay, so that's one type of question you might see. Okay, so here's another practice, and we'll end with this one. It says the student needs to make 2 liters of a 0.3 molar solution of sodium fluoride, and this one's asking how many grams of sodium fluoride are needed. So this is a little backwards from what we've been doing. So we got to start out with our equation again. And again, always go back to this thing if you're not sure what to do. And when I see, words like grams, like we have here, I automatically think, okay, I've got to figure out the moles. They gave us this. They gave us that. I need to figure out that because grams and moles are cousins based on what we've learned up to this point. Okay. So I have to rearrange this equation. So if liters are on the bottom here, I need to get them over to the other side. So they're going to go next to the molar part, the M, the capital M. So this is the equation after doing my algebra. Okay. So I plug in my value of 0.3 molar here. I plug in the 2 liters there. And I do the math, it's just multiplying now. The liters are going to cancel out, and you notice that gives me the moles. Remember, if you take care of your units, they will take care of you. So putting things in there properly is really helpful. And you notice I wrote this as the fraction of moles over liters instead of capital M, and that's just to remind myself that it is a rate and the liters will cancel when I do that. Okay. Once I have the moles of sodium fluoride, then I convert it to grams using dimensional analysis like you've done so many times. Again, the 42 grams is coming from the periodic table masses. That's the molar mass of sodium fluoride. It's 0.6 times 42, which comes out to about 25.2 grams of sodium fluoride. Now, here's what this means. If I need to make this solution for a teacher, for a lab, or have the students do it for me, they would take this and go weigh it on an electronic balance. They'd weigh out 25.2 grams of sodium fluoride, and they'd either get a beaker or Erlenmeyer flask. They would put that sodium fluoride in there. Then they're going to add H2O until that volume gets up to, in this case, 2 liters. Now, normally in chem we use milliliters, so you may have to do some more conversions there. But for this example, we would have to add water until we got to 2 liters. You don't want to put the water first. Water first is going to be a problem, because if you put the water first and then add the 25.2 grams of sodium fluoride, the volume is going to go up, which is not good. Then you don't have 2 liters. Okay, you'll have slightly more than 2 liters. So those are a couple of common practice questions that you'll run into in this portion of the unit, but they're definitely doable. Follow these notes and this video when you're working on practice that I'll give you. Okay, hope you guys found this helpful, and we'll see you soon.